Sugar-Sweetened Beverage Intake and Childhood Obesity, presented by Amy Herman. To fully understand the concepts presented in this presentation, definitions of important variables must be provided. For purposes of this project, sugar-sweetened beverage can be defined as any drink containing added sugar, including sodas, fruit drinks, Kool-Aid, and sports drinks, but excluding diet soda and 100% fruit juice. Definitions for overweight and obese used in this project are consistent with the definitions found on the Center for Disease Control website. Overweight is having a body mass index of greater than the 85th percentile, but less than the 95th percentile for age and gender, while obese is defined as having a BMI greater than the 95th percentile for age and gender. The number of obese children and adolescents has skyrocketed in recent years. According to the World Health Organization, childhood obesity is among the most serious public health crises of the 21st century. In fact, from 1970 to 2010, rates of childhood obesity in the United States have nearly tripled. And as of 2012, 1/3 of American youth were considered to be overweight and/or obese. So why does this matter? Obesity in childhood carries with it both immediate health risks, such as hyperlipidemia, hypertension, bone or joint problems, and poor self-esteem, as well as long-term health risks, including heart disease, stroke, type 2 diabetes, cancer, and osteoarthritis. Research has also shown that children and adolescents who are overweight are more likely to be overweight and/or obese adults. Furthermore, obesity has a direct effect on healthcare costs. It is estimated that $190 billion was spent on obesity-related healthcare in the United States in the year 2005. So why do we care about sugar-sweetened beverage intake? Sugar-sweetened beverages are the largest source of added sugar in the U.S. diet, and in children are the source of up to 224 additional unnecessary calories per day. Many researchers have linked consumption of sugar-sweetened beverages with increased risk of being overweight or obese. One study demonstrated that for each additional 12-ounce can of soda consumed per day in children, obesity risk increased by 60% at 1.5 years follow-up. An additional review revealed that the addition of one sugar-sweetened beverage per day led to BMI increases of 0.6 units. The same review also demonstrated reductions in BMI when sugar-sweetened beverage consumption was decreased. Furthermore, the CDC not only links sugar-sweetened beverage intake with obesity, but also claims that limiting sugar-sweetened beverage intake can help maintain a healthy weight. To examine the relationship between sugar-sweetened beverage intake and weight gain in children, 3 studies were reviewed. The first, performed by DeBoer, Scharf, and Denmer, was a longitudinal cohort study that aimed to assess the relationship between sugar-sweetened beverage intake and weight gain in children ages 2 to 5 years old. Data from the Early Childhood Longitudinal Survey birth cohort was utilized. Participants were selected via random sampling, resulting in a final sample of 10,700 children born in 2001. Participants were then examined at 2, 4, and 5 years. Exposure was measured via parent interviews conducted at each of the waves. Beverage intake was calculated based on parent response. One 8-ounce beverage was considered a serving size. Children were then categorized as frequent drinkers, drinking 1 or more 8-ounce sugar-sweetened beverage daily, or as infrequent drinkers. Outcome was measured by trained researchers using standardized protocol to obtain height and weight measurements at each wave. These measures were used to calculate BMI percentiles using CDC growth charts. Children younger than 24 months at the 2-year wave were excluded as BMI is not validated below this age. Data was analyzed by using SAS software. Data analysis revealed an increased odds of overweight and obesity at age 4 and at age 5 years for regular drinkers when compared to non-drinkers. However, after adjusting for possible confounding variables of gender, race or ethnicity, mother's BMI, socioeconomic status, and television viewing, the only statistically significant data was an increased odds of obesity at age 5 with an odds ratio of 1.45 and 95% confidence interval of 1.1 to 1.85. Lim et al. Also conducted a longitudinal cohort study to assess the relationship between sugar-sweetened beverage intake and overweight or obesity. Data for this study were obtained from the Detroit Dental Health Project, which was a 2-year longitudinal cohort study. 2-stage stratified sampling was utilized to select participants. The final population that met criteria for analysis in this study included 365 children ages 3 to 5 years old. Of this 365, 275 were normal weight at baseline and were used to analyze the incidence of obesity and overweight in relation to sugar-sweetened beverage intake. Exposure was measured using the Block Kids Food Frequency Questionnaire, performed by trained interviewers. Collected dietary data were quantified in milliliters per day. Outcome was measured by obtaining heights and weights using standard protocols. These measurements were utilized to calculate BMI, which was converted to BMI Z-score based on BMI percentile for age and gender. Statistical analysis was performed using descriptive statistics. Overweight and obesity incidence was measured at 2 years follow-up. After adjusting for the following confounding variables of baseline beverage intake, BMI, age, gender, caregiver's education and income, children's baseline dietary intake, and caregiver BMI, the results revealed a 4% increased odds of becoming overweight per ounce of sugar-sweetened beverage per day consumed. These results were significant, with a 95% confidence interval of 1.01 to 1.07. A third longitudinal study performed by Pan et al. Utilized data from the Infant Feeding Practices Study 2 from 2005 to 2007 to examine whether sugar-sweetened beverage intake during infancy predicts obesity at 6 years. 1,189 participants from that original study were analyzed in the Year 6 follow-up study. 3 exposures were measured: sugar-sweetened beverage intake during infancy, age at sugar-sweetened beverage introduction, and mean weekly sugar-sweetened beverage intake during ages 10 to 12 months. Data was collected via parent report from study questionnaires. To measure outcomes, mothers followed instructions on measuring height and weight of their child. These measurements were utilized to calculate BMI percentile based on CDC growth charts. The covariates controlled for include gender, birth weight, solid food introduction before 4 months, breastfeeding duration, mother's age, mother's pregnancy weight status, maternal race ethnicity, maternal education, marital status, and household income to poverty ratio. After adjusting for covariates, it was determined that any sugar-sweetened beverage intake during infancy resulted in a 71% increased odds of obesity at 6 years follow-up, with an odds ratio of 1.71 and a 95% confidence interval of 1.09 to 2.68. In addition, if sugar-sweetened beverage intake were introduced before 6 months of age, there was a 92% increased odds of obesity at 6 years, with an odds ratio of 1.92 and a 95% confidence interval of 1.01 to 3.66. Furthermore, for those that consumed greater than equal to 3 sugar-sweetened beverages a week during ages 10 to 12 months, there was double the risk of obesity at 6 years follow-up, with an odds ratio of 2.0 and 95% confidence interval of 1.02 to 3.9. In reviewing Henneken's criteria for causality, all 3 articles contain statistically significant data according to analysis of their confidence intervals. However, all 3 studies introduced bias. All 3 studies relied on parent recall and reported their child's sugar-sweetened beverage intake, which could lead to underreporting. Furthermore, the 3rd article relied on height and weight measurements obtained and reported by the mother. In addition, while all 3 studies controlled for multiple covariates, none of the studies controlled for all possible confounding variables that may have affected the outcomes of the study. Finally, both Article 2 and 3 were subject to sampling bias, and therefore were not representative of the general population. Article 2 utilized only low-income African American children, while Article 3 relied on women that were part of a consumer opinion mail panel. As mentioned previously, many confounding variables exist that may possibly affect study results, and while the studies did control for many of these, there is no way to control for all possible covariates. Strength of association is another important element of Henneken's criteria. For this project, strength of association was determined using strength association criteria provided to the class in week 7 to interpret the adjusted odds ratio for each study. Based on this criteria, the strength of association for Article 1 was weak, Article 2 was none, and Article 3 was moderate. All studies demonstrated the criteria of biological plausibility and temporality. Consistency is an issue that needs to be addressed. Limited studies in this population exist, making consistency something difficult to establish. However, similar results have been seen in studies with older children. Additionally, dose response was noted for both Articles 1 and 3, but not Article 2. Both Articles 1 and 3 showed increased odds of obesity or overweight with increased sugar-sweetened beverage consumption. When reviewing this criteria, Article 2 appears to be the weakest of the 3 studies due to having no strength of association, lack of consistency or dose response, and because it samples only low-income African American children and is therefore not representative of the overall population. In conclusion, all 3 studies reviewed demonstrate an increased odds of obesity or overweight associated with the sugar-sweetened beverage consumption in young children. However, while many studies demonstrate this relationship in older children, limited studies that analyze the relationship between weight and sugar-sweetened beverage intake in the preschool age group exist. Hence, more studies are needed to demonstrate consistency of the outcome. The outcomes of this project have many implications. First, lifestyle patterns and habits are still being developed during young childhood years. Therefore, it is crucial to establish healthy life patterns at early ages. Because of this, pediatricians should educate parents on the harmful effects of sugar-sweetened beverage consumption and highly discourage their use in young children. Finally, policy changes that limit sugar-sweetened beverage consumption should be developed and considered.